Hi everyone, welcome back. So we have learned in a last video about the NumPy library that how to create arrays in a NumPy library and some of the attributes and methods we can apply on the top of this n-dimensional array of this NumPy. Now we'll see what is indexing in a NumPy and how to select particular element from this NumPy array. So for demonstration purpose, let's create one array first. So I'm going to give the name like a ARR, like array, and let's use this A range. Let's create a array which is having a value 50 to 70. If I just display it, 50s 51 up to 69 it has created, and if we just put, let's say, array dot shape, total 20 values are there. Now let's talk about first indexing. So let's say if you want to grab some particular element of this array, so let's talk about the 54. Okay, so indexing is nothing but every single number is referencing to some value in this particular array. So indexing, you can say like a memory address. So 0 is pointing to 50, 1 is pointing to 51, 2 is pointing to 52. Same way 9 is pointing to 59, and then 10 is pointing to 60, 11 is pointing to 61. Same way at the end 19 will be pointing to 69. So let's say if you want to grab, let's say 54, so here the indexing is starting from 0. So 0, 1, 2, 3 and a 4. So just need to put 4 in a bracket after this array. So it has written a 54. So let's try with this 68. Okay, array. Now what indexing value we have to provide, because from it's starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have to just provide 18. So it has written as the 68, because this is, you can say, like a 18th element of this particular array, and here the element reference indexing are starting from 0. So this is how you can grab a single element. Let's say you want to grab all element after, let's say, 59 or let's say 58. So all this element we want to grab it. So in this case we have to use the slicing notation. So I'll write here the common syntax for slicing, like inside the bracket first you have to pass like a start index. After that you need to write like a colon and then end index. Okay, now array. Now after what we have decided, something like a from 59 or maybe 58 to 69 we want to grab it. So what is the start index? So 58 will be a start index, 69 will be an end index. So 58 has been referenced by number 8. So let's put 8 starting, and end will be definitely 19. So now you can see 19, but upper bound is always excluded. So that's why 19 didn't got included. So in that case we have to put the 20. Even though 20 index number is not available, this 20 will be anyhow going to exclude it. So it has written as the 58 to 69. Now as we want to grab rest of the element after this 58, so in that case you do not need to write even this 20. So in that case you just put after 8 colon and nothing. So every single element after this 58 will be included. Same way, let's go with the little reverse way. Now starting from this 0th element, you want to grab, let's say, first 5 element. So 50, 51, 52, 53, 54. Okay, so one thing you can do, like from 0 to 5 you can put it. So 5 is pointing to 55, but we don't want to include 55, so only 5 element will be included. So you can see 5 element. Now as we want to start from very much 0th element, you do not require to write this 0 even. So start index position or start index, we will just keep it like a blank, and end index, let's keep it like a 5. So from the starting of array, the first 5 element it will return. Let's say instead of just 5 element you want to grab the first 7 element, so you can just put like 7 element. Yeah, no need to require this space, actually just for the visualization purpose I have kept it. Okay, so this syntax will be used to get first 5 elements. Same way this will be used to get all the rest of the element after this 8 index. You can even use the negative indexing also. So the element which is at the last you want to grab, instead of starting with like a 0 and a -0, you can start with a -1. So in this case the -1 is pointing to this 69, the last element. Yeah, this one. So you can see 69 it has written. Same way you can grab it like a -2, so it's a 68. Okay, so this way the indexing works in a NumPy array, and how you can extract a particular element or a list of element from this NumPy array. Now let's do some operation what we can perform on the top of this NumPy array. Let's say you want to grab that how many of those total element is, let me print first full array, are greater than, let's say 55. So I can just simply compare with a 55, and every single element in this array will be compared with a 55 and it will return true or false. So wherever the element is greater than 55, it has written, let's see, it has written true after 55. For remaining all element it has written false. And if you just do the sum, you can see 14, which indicates that there are total 14 elements, which is true, which eventually indicates that those elements are greater than 55. Or let's say you want to add some 100 to every single element, so you can just simply use like a array plus 100. So 50 becomes 150, 51 becomes 151, 52 becomes 152, which indicates that every single element of this array object has been added with 100. Let's say you want to subtract 20 out of every single element. So 50 become 30, 51 become 31. Same way you can even multiply also. So let's say you want to multiply every element by 2. So 50 become 100, 51 become 102. You can even divide also. So 50 become 25, 51 become 25.5. Okay, so this way every single element can be operated such a kind of syntax in a NumPy array. So this indexing and selection of element we have seen in a one-dimensional array. Now let's try with a two-dimensional array. Same thing, similar index, but similar way we will access the element, but now we are going to operate on a two-dimensional array. So first let me create one random array. So mat, I will create it in p dot, let's say random, let's say rand. Okay, so 5 cross 5 matrix I will create. Oh sorry, and if I just display it, you can see we have created this 5 cross 5 matrix, or I would say 5 cross 5 NP array. Now here the indexing value or every single element available in this matrix can be referenced with a 2 number, because earlier it was referencing with a just 1 number in case of one-dimensional array. In this case it will be referenced with a 2 number. So one is a horizontal row and one is a vertical row. So let's say here also indexing are starting from 0. So this is the 0th row, this is first row, this is the second row, and this is the third row, and this is the fourth row. So this way 5 different row will be addressed. Same way this is the 0th column, this is the first column, this is the second column, third column, and a fourth column. Now let's concentrate on the common way of syntax. So matrix, so first you have to give like a row level stuff, then comma, and a column level stuff. Okay, so in row how many elements what you want to access? You want to access single element, or you want to access number of different rows. So everything you can put it before this comma, and after comma you have to put it like a column related information. So let's try to grab the very first row and first column element this way, this 0.263. Okay, so this comes under the 0th row and definitely the 0th column. So you can see 0.263. Let's try with another one. So let's say this one we want to grab. Now this comes under total 3rd row. Numerically it will be in a 4th row, but as indexing are starting from 0, this is in a 3rd row and this comes under the 2nd column. So 3rd row and a 2nd column. So you can see exactly the same element we have retrieved. Now this is just the matter of single element. Let's say you want to grab one particular full row only and every single column. So let's say the first row we want to grab this one. Okay, so the first argument we have to supply it like a 1, and as we want to grab every single column, better don't supply anything. So you can see first row it has written 0.41, 0.78, 66 and again 66 and 21. Okay, so now let's say you want to grab instead of rows the full column. Okay, so in that case you have to use the same syntax. So first you have to put the rows. Now every single row we want to extract because we are interested in a last column only. So last column contains every single row. So in this case just put the colon, comma, and the last column will be referenced with the number 4. So you can see now 0.67 and 0.21, 0.17, 0.06 and 0.98. So this way you can grab the individual rows and columns. Now let's say instead of just one row you want to grab more than one row or sets of rows. So you can use like a, let's say just the first row you want to grab these 3 rows. So from first, second and third. So first to 4th row you want to grab it in every single column. So in case of column I am not going to put anything, or you can simply put like a colon because every single column you want to retrieve it. Now you can let me print it again and you can compare it well. So 0.41, this is what exactly we have got. Okay, same way let's say you want to grab first and a second column only. So every single row you want to grab, so in place of row you just keep it like a colon, comma. Now first column, or I would say this is a 0th column and a first column. So from 0, 1 and then 2. 2 will be anyhow excluded because upper bound is always excluded. So you can see 0.26 and 18, 41 and 78. This way you can grab it. So this way you can grab multiple rows, multiple column also. Now at a one shot only, let's say you want to grab this 4 element. So this don't include this one, and this is just because of selection. So this 4 element I want to include this one, this one, this one and this one. So this comes under first row, second row. So let's make highlight like a first row and a second row. And this comes under the 0th column and a first column. 0th column and a first column. Okay. Now let's put it into bracket notation. So first we have to put like a row. So from 1 to we have to keep it like a 3 because 2 also we want to include it. And then for the column from 0 to let's say 2 because 0 and 1. So you can see 0.41 and 78, 0.86 and 0.26. So this way you can practice yourself and try to grab different sets of data with the help of this indexing and selection and a slicing mechanism. This colon is nothing but the slicing because you are slicing your original matrix or original NumPy array into some subarray. Okay, so this is how you can do this indexing and selection of some particular element out of whole NumPy array. Now let's see some more functions available inside this NumPy. So we have already this array. Now let's say you want to find the trigonometric cosine value of every single values available in this array. So we have a ready-made functions are available like np.cosh, and you can just simply pass like array. For every single value available in this array, it has calculated the cosine value of it. Same way you can find let's say 10 value. So we won't go into detail much about every single functions. So for all this 20 value, it has find out the tangent value. Let's see some more functions. So let's say you want to find the sum of every single value available in this array. So you can use like a sum in array. Let's say you want to find the average value of every single value available in this array. So you can use like a mean method. So average value will be 59.5. So this way there are a number of different functions are available inside this NumPy library. You can try it out yourself, but my objective and intention behind this two video of this NumPy library and NumPy section is to get you introduced that whenever you want to represent your data, it is one of the very high performance library available in a Python to represent your data in a one-dimensional, two-dimensional or multi-dimensional platform, and you can do all those processing at a very much faster rate, and you can do all those kinds of linear algebra and matrix manipulation related processing. Okay, so that's all about this video.